like we completed the centenary of our founder, and our college is 45 years old. So let us have a video of our institution.
ಇದು ಚೇತನ್ ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ ನೋಡಿ ಸರ್. ನೋ ವಾಯ್ಸ್. ಚೇತನ್ ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ ನೋಡಿ ಸರ್. ನೋ ವಾಯ್ಸ್.
Live the dream, seize the time, seize the day, make your way. Live the dream, seize the time, seize the day, make your way. Live the dream, seize the time, seize the day, make your way. Seize the time, the dream, seize the day, seize the time, make your way. Seize the day, make your way. Seize the time, seize the day, make your way. Live the dream, seize the time, what you seize the day, make your way. Seize the time, seize the day, make your way.
There is a small request. We request the sound disturbance because of that. The department video.
Namaskara. Civil engineering is known as the mother of all branches of engineering. It is a broad discipline that unifies the specializations like environmental engineering, water resource engineering, structural engineering, pre-stressed concrete, construction technology and management, highway engineering, geotechnical engineering, and architecture and town planning. The Department of Civil Engineering started in 1979 with an intake of 60. Now we have an intake of 180 with 2 PG programs, structural engineering and highway technology. We have accredited to NBA from 2005. We have well-equipped laboratories. As you are aware, civil engineering profession involves planning, analysis, design, construction and maintenance of different types of structures for government and private sectors. These include high-rise buildings, schools, colleges, airports, dams, harbors, tunnels, all these. At the same time, civil engineers also plays a dominant role in wastewater management, solid waste management, biomedical waste, electronics waste. Civil engineers keenly observe and identifies the problems faced by the society and also develops appropriate solutions based on technical feasibility, economics and sustainability. Civil engineers are creative and yet practical. We have well-developed consultancy cell working closely with the Ministry of Road Development and Panchayat Raj, Ministry of Water Resources Department. Visit our college, department. Our research and development reflects what we are.
To facilitate the academics, consultancy and research, the department houses state-of-the-art laboratories and computer facilities. All laboratories are equipped with modern testing equipments and latest design software to meet the curriculum and present industrial requirements. KIOCL Center of Excellence Lab provide researchers facilities to conduct research on solid waste generated by industries. department is having Sukritya Students Club, which is actively functioning in the field of technical, cultural, societal, sports, and other extracurricular activities. Under this club, Swachh Bharat program is organized every year in and outside Bangalore, emphasizing on clean and sustainable environment. Department is having professional body memberships with renowned professional bodies of India. Technical fest, conference, workshop, and symposium will be organized every semester in association with major funding agencies of India. Field trips and hands-on learning make concepts more memorable. Our branch that is more related to fieldworks have ensured to give the students exposure by organizing field visits to various places such as water treatment plants, construction sites, irrigation and dam sites, etc. Also, extensive survey camp is a part of the curriculum for the students of 6th semester. Every year, the camp is conducted for a duration of 10 days at Melukote in Pandavapura Taluk of Mandya district, Karnataka. Around 4,000 engineers have graduated from the department since 1979. The alumni of the department are a part of national and international projects, and many are leading entrepreneurs. To name a few, our alumni are rendering their service in Indian defense, Indian administration, politics, arts, sports, research, and academics.
Thank you, Chetan. Now I request Dr. H.K. Ramaraju, Head Civil Engineering Department, Vice Principal DSE, Honorable Secretary IPHE, and Honorable Director International for IVA to welcome the gathering formally.
Good morning to all. Engineers Day 2022. The birthday of Bharat Ratna Sir M. Visvesvaraya. Dayananda Sagar College of Engineering, in association with Indian Waterworks Association, Bangalore Center, and Institution of Public Health Engineers, Karnataka State Center, we are togetherly organizing this webinar. Friends, the theme for today's Engineers Day program proposed by Institute of Engineers is specifically on smart engineering for a better world. The world is experiencing rapid urbanization. At the same time, the technological development also playing a dominant role in the various fields, such as artificial intelligence, IoT, cloud computing, etc. Using drones, total station service, GPS, GIS, all these are playing a dominant role in day-to-day life. Specifically, if you come to the civil engineering field, we have 3D printing, BIMs, cloud computing, and there are other the big data. It has become a powerful tool for the civil engineers. So all these, now the technology development, we engineers have to use it effectively in implementation in the society for the benefit of the community. Badalavane, change, Prakriti Niyama. 1950ರ ದಶಕದ ಡಾಕ್ಟರ್ ಡಿ ವಿ ಜಿಯವರ ಮಂಕುತಿಮ್ಮನ ಕಗ್ಗದ ಕೆಲವು ಸಾಲುಗಳನ್ನ ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀನಿ. ಪ್ರಕೃತಿಯ ನವರತ ಮನುಜ ತಿದ್ದುತ್ತಿರುವಂತೆ ವಿಕೃತಗೊಳಿಸುವನಂ ಆಕೆ ಎಂಗಗಳ. ಭೂ ಕೃಷಿಕ ಶಿಲ್ಪಿ ವಾಹನ ಯಂತ್ರಿ ವ್ಯಾಕೃತಿಸರೇನವಳ ಮಂಕುತಿಮ್ಮ. ಹೌದು, ಹಾಗೆ ಮುಂದೆ ಮತ್ತೆ ಹೇಳ್ತಾರೆ ನೋಡಿ ಮತ್ತೊಂದ್ ಕಡೆ, ಹೊಸತನವೇ ಬಾಳು, ಹಳಸಿಕೆಯಲ್ಲ ಸಾವು ಬಿಡು, ರಸವು ನವನವತೆಯಿಂದ ಅನುದಿನವು ಹೊಮ್ಮಿ ಹಸನೊಂದು ನಡೆಯಲ್ಲಿ ನುಡಿಯಲ್ಲಿ ನೋಟದಲ್ಲಿ ಪಸರುತ್ತಲೆ ಬಾಳ್ ಚಿರುವು ಮಂಕುತಿಮ್ಮ. These are the words which are written by Dr. DVG in his Mankutimman Kagga almost a century back. Dear friends, we engineers have to use the technological advances effectively to satisfy the needs of the society. Today's webinar, what we are conducting now in association with the IVA and IPHE. For that, this program, I would like to cordially invite our mentor, Shri Engineer Srinivas Reddy, who is a philanthropist too. He morning only gave me the call and told, because of other unforeseen the happenings, he would have to attend that program. So immediately he just gave me the call and passed the message that my absence cannot be taken, Ramaraju, because it should be considered positively. I have to attend some other works, which is very, very important. I have to visit the Narayana Rudralaya and all. So he went there. Anyway, in his absence, I thank him for accepting this program. At the same time, for all our programs, our major backbone is our principal, Dr. C.P.S. Prakash. Sir, I welcome you for today's webinar. At the same time, our major speaker, because she is the focal point of the today's program. Madam Bindu Sunil is here with us, who is the director of Geostructures Private Limited, Ernakulam, Kerala. She is going to deliver a talk on learning from mistakes, case studies. Definitely, it is a very good talk. I request all the participants to listen to those things. You will understand how exactly the history has started as a lesson. The lesson is a step for us to move forward in a positive way. Anyway, I welcome Ms. Bindu Sunil for today's program. At the same time, our IPHE, welcome you, ma'am. Our IPHE, Institute of Public Engineers, our chairman of the IPHE Center, Shri Malik is also with us. Sir, I welcome you for today's program. And I welcome all our faculties of the Department of Civil Engineering and the faculties from different corners of the country. They are already participating. Almost the strength is almost nearly 125 or something like that. Of course, from different parts of the country, they are already into the they are logged in. At the same time, I welcome our students from the engineering colleges. They are also in the they have registered and attending this program. At the same time, all IVA, Indian Water Works Association and Institute of Public Engineering members, the media, all I welcome you all for this program and thank you all. Thank you. Over to Neetu, please.
Thank you, sir. Let us start today's function with the blessings of Almighty. I request Chetan to play a video on virtual lighting of land. Thank you, Chetan. Now I request everyone to switch on the video mode for a few seconds so that we can have a virtual group photo.
I think you can ask the students also. I think students are worried whether they have to open their video.
Students, please switch on the camera for few
Right.
seconds.
Yeah, please switch on the cameras, please. We request the students too.
Okay. Thank you all. Now, I request our beloved principal, Dr. CPS Prakash, to address the gathering.
Good morning.
Okay, sir, I will start the work and I will talk
Sri
to
Malik
you.
RP from IPHE. Sri Srinivas Reddy from Indian Water Works Association. Speaker of the day, Madam Bindu Sunil. Dr. Ramaraju, Professor and Head of the Department of Civil Engineering, Vice Principal DSCE, all my esteemed colleagues, invited guests of various professional organizations, my dear student friends. At the outset, let me wish you all a happy Engineers Day. What a better occasion to have an excellent theme for the talk that has been organized to commemorate the birth anniversary of the greatest son of the soil, Mokshagundam Saram Vishveshwaraya. Learning by mistakes. My dear student friends, we being engineers, in the journey of contributing to the society, as you saw just now in the video, Mokshagundam Saram Vishveshwaraya was known for his honesty, hard work, sincerity. So being engineers, one of the basic traits, some of the basic traits that we need to have is we should be very good in conceptualization, meticulous planning, implementation with effective supervision. For doing this, we will have to coordinate with various agencies in terms of optimized and better utilization of resources, especially being civil engineers, it becomes very essential. So in the process of undertaking any work, there is all possibility of doing some mistakes. And just now, as rightly put by Dr. Ramaraju, we have to learn from the mistakes that we do in our day-to-day work and move forward by fine-tuning the way we apply the principles that we have learned, the knowledge that we have, so that we improve day by day in whatever the work that we are doing. So from that point of view, I feel we are celebrating Engineers Day in much more meaningful way. My dear student friends, please listen to the talk given by Madam Bindu Sunil today. Probably I am also sitting through the talk. Whatever that she is going to talk will definitely be useful and add value to each one of you. And once again, wishing you a happy Engineers Day. Wish you all become better day by day and be effective learners, so that when you graduate from the portals of Dayanand Sagar College of Engineering, you should all be successful and march in the footworks of Mokshagundam Saram Vishveshwaraya. I thank Professor Ramaraju and all the coordinators for giving me an opportunity to be part of such a wonderful event, and wishing you all the best. I sign out. Thank you.
Thank you, sir. Thank you very much. We are very fortunate to have this busy person, Mrs. Bindu Sunil. She is a very busy person because she is always involved in one or the other problem-solving techniques related to structural and geotechnical engineering. She has agreed to address you all today on the topic, learning from mistakes, some case studies. I request Professor Meghashri to introduce today's speaker.
Thank you, ma'am. Good morning to all the dignitaries and students. It's my immense pleasure to introduce our speaker of the day, Ms. Bindu Sunil. Ms. Bindu Sunil has completed her BTech from TKM College of Engineering, ME in Structural Engineering from PSG College of Technology, Coimbatore. Madam started her career as design engineer with ENARC at Thrissur. Presently, she is the director in Geostructurals Private Limited, Ernakulam, Kerala. Madam has completed more than 1,500 structural consultancy projects comprising of multi-storied buildings, residential buildings, institutional buildings, industrial, religious, infrastructural, and IT tech parks. Madam is also member of many professional society chapters in India. To name a few are Geotechnical Society Cochin chapter, member of Institution of Engineers, life member of Indian Concrete Institute, member of Indian Structural Consultants Association. On behalf of Department of Civil Engineering, DSE, I wholeheartedly welcome you to this program, ma'am. It's a privilege to listen to your talk today. Thank you.
Over to you, ma'am. Ma'am, I think it is, yeah.
Yeah. Thank you for the good words. A very good morning to all of you, to Dr. Prakash Sir, Principal, Professor H.K. Ramaraju, Dr. Needu Urs, and all who are here celebrating the birth day of our Vishwesvaraya Sir. So a happy Engineers Day wishes to all of you. And I thank you for giving me this opportunity to share a few of my small experiences with you here. So shall I start sharing the screen, Dr. Neetu?
Sure, ma'am. Sure, ma'am.
Yeah. I hope you are able to see my screen.
Yes, ma'am.
Okay. So the topic I have chosen to present here is learning from failures. So since I'm working in the construction industry as a structural consultant, it will be learning from structural failures in the construction industry. The theme given to me by Dr. Neetu was smart engineering for a better world. So I thought learning from mistakes is a smart way of doing things. We can learn from mistakes done by others earlier so that we need not repeat them. So we need to reflect upon our experience as well as past experiences or failures our ancestors or people before us had done, and we can learn from them, and we can make sure that we do not repeat these mistakes, and we will lead a better, or we will have a better or more efficient system. Like Henry Ford said, the only real mistake is the one from which we learn nothing. So a mistake remains a mistake if we learn nothing from it. But a mistake can be turned into a stepping stone to success if we analyze the mistakes, find out the cause effects, and then learn from them. Abraham Lincoln once said, if I had 6 hours to chop down a tree, I'd spend the first 4 hours sharpening the axe. So sharpening the axe means we will have to prepare for the job in
Ma'am,
front of
excuse
us.
me. Ma'am, excuse me.
Yeah,
Are you changing the slides, ma'am? We are not able to see.
you are not able to see
Yeah, we are able to see the first slide.
only the first slide.
Yes.
Okay, now are you able to see?
No, ma'am.
No, okay, so let me check.
Click on the second. I think if you click, it will be seen.
Put it onto presentation mode, madam.
Hello?
Yeah, ma'am. You can change it to presentation mode. F5 key. Yes, ma'am. Now we can see. Can you just show us the missed slides also, ma'am? It seems to be very interesting. Second slide. Yes, ma'am. Yes. Yes, ma'am. Now it's clear. We can see.
Presentation mode is there. Mode delay. Huh? The mute and sound. The video. Eh? Mute the video. Video. Hmm? Done. Are you able to see my screen?
Yes, ma'am. First slide.
Okay.
First slide.
Second one.
Ma'am, I
Second
think,
one?
yeah. You have to click on each slide. Otherwise, F5 key will work, ma'am.
Yeah.
If you use keyboard, we cannot see. You have to click on every slide, or else one more option is F5 key.
Now this second slide, are you able to see?
No, ma'am. Click on it again. Or else you can use F5 key, which is the presentation mode.
Now the second slide you are able to see?
No, ma'am.
No, I have clicked on it. 1 second, I experienced
No problem, ma'am. No problem.
this difficulty, first time, because earlier I've done no difficulty in sharing it. So let me check.
Okay, ma'am. Yes, ma'am. Now we can see. Ma'am, this is better. We can continue like this. Yeah.
Okay. Okay. So yeah. So let us learn from the mistakes and deliberate upon them, the cause, reason, and the effect, and then understand and learn from the mistakes. This one, are you able to see?
Yes, ma'am.
Yeah. So yeah,
Yes.
if we have a we have to do a job, we have to be prepared, and for the preparation we will have to understand what are the pitfalls we might face in the past, and we will have to be prepared for those, and the past experiences of our ancestors will lead us and tell us what the best way to do it. So as usually says, a doctor can kill a person on a surgery table, only one person will die. But if a bad engineering work is done, thousands of people can die. I will share a small video showing this. I hope you are able to see the video.
Yes, ma'am.
Yeah. Okay. So moving on to the case studies. Here I am trying to. I have planned to present 5 case studies which I was involved in. Our company was involved in some way or the other. Some projects we were the primary structural consultants, and in some projects we were peer reviewer. So this is a hospital building, and this is with respect to a scaffolding failure. So here we were the primary structural consultants, and we supervisory role was not given to us. We issued the drawings, and before designing the structure, we had visited the site and understood the topography, and we designed the structure and gave. It is a hospital building with 3 basements and 6 floors. The floor heights are as follows. Basement 3, the lowest basement is 4.2, basement 2 is 3.9, basement 1 is 4.2, and ground and the 5 upper floors are all 4.2 meters. So the problem happened when a porch slab, a front porch slab, spanning an area of 10 meter by 50 meter collapsed while concreting was being done. So this is the area. This is the picture showing the area where the collapse happened. This is the highlighted area is the portion where the collapse happened. Side picture of collapse after it happened. So half portion of the slab was collapsed while concreting was going on. So later when we visited the site, we could see that the scaffolding system provided, the supporting systems provided were not at all up to mark, that it is a miracle that only half portion of the porch slab collapsed. So if you can see, this is how the supports were, the props were supported. So these are all broken bits of piles. Then the supports are not through and through. It is haphazardly supported on a bent wooden piece, and then the across span is provided. Above that, another vertical member is provided. The proper diagonal or horizontal bracings are not there. So these are pictures highlighting how the collapse happened. So why did it collapse? The vertical props and across spans of the scaffolding system were of poor quality and in bad shape. Supporting jacks were extended to its maximum length, leading to large slenderness ratio, and there were no proper horizontal or diagonal bracing for lateral stability of the system. Broken concrete cubes were used for supporting the props. The base of these props were not properly supported. The geometry of the scaffolds or staging was not correct for a smooth load path to transfer the heavy concrete load to the ground. The scaffold supports are placed on ground without proper ground compaction or any larger base to distribute the load without any settlement. So what we can learn from this failure? We have to understand that scaffolding system is also a structural system supporting some loads, and design of scaffolding system is as important as designing the structure itself. Like we do for the superstructure, a proper load distribution path has to be maintained and has to be established in the system. The total load to be carried by the scaffolding system should be assessed, and the member supporting it, the horizontal as well as the vertical member supporting the scaffolding, should be properly designed, taking into account the operational loads, the span of the beams, etc. It has to be borne in mind that the weight of wet concrete has to be taken into account, the live load due to the man and machinery over, and the pumping impact load on the shuttering due to the pumping of the concrete, etc., are to be taken into account. The vertical support should be checked for the total vertical load expected on the care being taken to understand its slenderness ratio, permissible stresses, etc. And the height of the staging or scaffolding should be checked. The proper bracings should be provided to prevent buckling and ensuing failure. Most importantly, like we say, the foundation or the base support should be properly seated, anchored, or held firmly in position at the base using suitable methods, so that sinking of supports, dislocation of supports, swaying, etc. are prevented. This is just a table by a manufacturer of some props, such materials, to understand how we can, as a preliminary idea, how we can understand what loads will be taken and what spans we can use. This is for across spans. If we can see for say 150 mm thickness of slab to be concreted, and taking a 1.8 kilonewton per meter square load, taking into account the operational loads of man, machinery, etc., a total load expected on it will be on the range of the range 5.4 kilonewton per meter square. And if they are placed at say 800 mm center to center, the span of the beam can be 4.35 meter. But we will have to again properly check. We will have to, this is just an indication on how to understand the design of a scaffolding. Again, this is for capacities of props. For props, what will be the vertical load coming on a prop, we can understand. We can estimate from the scaffolding diagram we are preparing. So whoever is the contractor will have to prepare a staging detail, and it will have to be vetted by a structural consultant, and the adequacy of the sections provided should be checked. Now, so this was with regard to failure of a scaffolding system. The second case is with regard to an IT building at Kakinad, where the concrete strength attained for columns were less than what was required. In this project, we were associated in this project as peer reviewers. So this is the details of the project. This is an IT building, about 5 lakh square feet, covering 5 lakh square feet area. It has 8 plus basement plus ground plus 19 floors, and the floor heights are written here. 3.4 is the ground floor height, then 3.15, etc. So the problem is that in the in 19 columns in the basement, ground floor and first floor combined, some 19 columns altogether had concrete strengths less than reduced by 35 to 40% than the required M45. The building has a basement plus 20 floors. Columns are spaced at 10 meter by 10 meter approximate grids. The concrete mix specified for columns in basement, ground floor, first floor was M45. Cube strength results for 19 columns in ground floor and first floor showed strengths way below the required M45. Since the cube strengths were less than what was required, additional tests were done to confirm the in situ strength of concrete. For that, rebound hammer test and core test were conducted. Rebound hammer test is an NDT test and core test is a destructive test. These were conducted to confirm the concrete strengths of various selected strength deficient columns. Finally, combining the results of cube strengths, rebound hammer test and core test, and as per the relevant IS codes, we tabulated the actual concrete strengths that can be attributed to each column. We found that the compressive strength values were found to vary by 30 to 45%, reduced by 30 to 45% from the required strength of M45. So why this reduction in strength happened? There are many reasons for concrete attaining lower strength than expected with respect to the mixed design. Use of low quality aggregates for concrete. That means we have a certain specific size and shape for the coarse aggregates for concrete. So if long and flaky aggregates are used, it will break and the strength of the concrete will be reduced. Then use of fly ash based cement. Fly ash based cement can of course be used, but it has to be judiciously done. So here there was some problem with the fly ash content, and that also contributed towards the long strength. Then low quality workmanship. Low quality workmanship comes the compaction of concrete, curing of concrete, etc. If all these things are not done properly, obviously the concrete strength attainment will be reduced. The nominal size of aggregate used at site mismatched with that used in the mixed design at the time of casting. That means the mixed design is done with available materials and a trial batch will be prepared and the concrete strength will be ascertained. But later on, when different types of aggregates, the components come, trial mixes for all these variations in the components are not done, and it may vary with the actual mix design and the site mix produced. Then change in cement used due to non-availability of earlier used brand. There was a change in the cement used. So when such things happen, again a trial mix should have been done. It was not done. All these things contributed to the low strength attainment. So as peer review consultants and local consultants, because the building is in Kochi, we were approached to give solution for the same, and we gave 3 solutions to it. One was demolish columns which have not attained the required strength and recast the members with M45 wherever possible. Wherever possible, just meant that certain columns with this low strength, the upper floor was not, the shuttering for the upper floor was not completed, and they were freestanding columns at that stage. So they could be easily demolished carefully, of course, without damaging the rebars, and then de-shuttered and reconcreted with the actual M45 concrete. For some columns, the upper floors shuttering was completed, and such columns demolition means it will be more difficult. So because the steel cages, reinforcement cages were also placed for the next floor beams. So we proposed carbon wrapping for such columns where a reduction in strength was less than 25%. And for columns with reduction in strength more than 25%, up to 45% reduction was there. So between 25% and 40%, the such columns were asked to be retrofitted by column jacketing, where additional concrete area and rebars are needed for the required capacity as per the analysis results. Retrofitting using carbon wrapping means carbon fiber reinforced polymers will be such things are readily available, and they have, like we use rebar, the strength specifications are there, and as per our strength requirement, we can use them. They can be tightly wrapped around the column, and the increase in strength is caused due to the confinement. So if a beam is of a low strength and we have to use carbon wrapping, then to increase flexural strength, longitudinal fiber reinforcements can also be provided. But here it was with respect to a column, and these carbon fibers were asked to be sufficiently overlapped and to increase the confinement and increase the column load carrying capacity. So these are some pictures showing how carbon wrapping is done. By column jacketing, this is just a sample detailing. The existing column will be this. We will have to increase the width and length of the column, and a minimum 75 mm will have to be provided. More will need to be provided if the strength, additional strength required is more. So here we propose 75 mm increment on all four sides. That means 15 centimeter altogether width and length of the column will be increased, and additional rebars were provided. And for connecting the new concrete to the old concrete, shear connectors were provided to ensure that load transfer between new concrete and old concrete happens. So this was how. So what we learned from this failure is proper periodic checking of mixed design should be done. So once a mixed design is done for M45, say, it cannot be used for the whole building. For each stage, when the cement brand or where the cement is acquired also has a impact in the strength. So all the components like cement, sand, force aggregate, and the workability agents, all these things play a good part in imparting the concrete strength. So when changes happen in the components, trial mix have to be again done. I mean, concrete mix design has to be done again. Trial mix has to be prepared to ensure the concrete strength, and then that mix has to be used. Fly ash content sometimes tend to lower concrete strength if not judiciously used with cement. So that also will have to be taken into account while preparing the mix design. For every change in cement mix, it is better to prepare a trial mix and confirm the concrete strength. Adequate quality control should be maintained during batching. Proper vibration and curing of concrete should be carried out. We can say that all these things everyone knows, but whatever basic things we know, they may not be judiciously and correctly applied at site. So that is the problem. If all these things are done correctly at site, such failures or mistakes will not happen. Now, this is with respect to a commercial building at Kochi. So here we were involved after a certain collapse happened in the building, and a technical committee was formed, and we were part of the committee, and the actual analysis and design part checking was done by us. So this is a commercial building. It has 3 basements, ground, and then 8 floors above. So as can be understood, with the 3 basements, there is a deep excavation involved. Here, the excavation from the existing ground level was 9.5 to 10 meters. And the problem was that the touch file system provided for the deep excavation failed. So this is the picture from the site after the collapse happened. This is just to understand how it is placed. This is the proposed site. There is a small building here, and this is a G+9 building, existing building, but it was on piles and it was not affected. This is the national highway, and metro, Kochi Metro was quite nearby the building. So this is a this is taken from the original geotechnical investigation report. The borehole locations. This is borehole number 1, 2, 3, 4, 5. So as can be seen, all the boreholes are taken within the footprint of the building. None is taken along the periphery or the near to the boundary to understand how the scaffolding system or the shoring piles will behave. So the soil profile, as can be seen, up to 5.7 meters, it is filling. with the N values as low as 2, 4, 3, etc. So up to about 12 meters, the soil is very weak and compressible with N values as low as 2, 3, etc. So, and in this borehole that I have shown here, soft rock was met with at 45 meters depth. This borehole was terminated at 45 meter depth, but we have 5 boreholes and some were taken beyond this soft rock also. So the foundation system provided was DMC piles extending to a depth of 47 meter, terminating in dense sand or hard rock. Accordingly, wherever this hard rock was further down, it was seated into dense sand with N value greater than 100 with a minimum penetration of 2 meter into the dense sand using M35 concrete. For the shore piles, the depth of excavation is 10 meters. So 30 meter deep, 90 centimeter dia touch piles were provided. And there were soldier piles provided inside the floor to support a strutting system provided to act as props for the touch piles. So this is a section showing the excavation needed. This is the road level. From here, 9.5 meters is the excavation needed. This is a basic touch pile retention system provided. This is the boundary, the touch piles. We can see the touch piles here all along the periphery of the floor. Then this is the probe system, strutting system provided.
These people
Hello?
are studying.
This is the system provided. The touch piles provided are 90 centimeter dia piles with a 30 meter depth, and the soldier piles are 60 centimeter dia piles with a 30 meter depth. In the construction phase, around 337 piles of 90 centimeter diameter piles were driven for touch piles and 28 number of soldier piles were driven. The touch pile system was designed as propped cantilever to resist the lateral loads as explained by the original structural consultant. Touch piles were done at the boundary by excavating a trench of 90 centimeter width and 1.5 meter depth in line and level, and alternate piles were done initially and then the in-between piles were done. So this was how the touch piles were done. After completion of shoring works, excavation was done in 3 phases. In the phase 1, excavation was carried out up to 2 meters. Then from 2 meter to 6.5 meter. In the last phase, excavation was planned up to 10 meter as directed by the structural consultant. Expecting clayey soil here, no dewatering system was suggested by the consultant here. So this is what happened when this is what happened when the excavation reached a depth of 9.5 meter. When the excavation reached a depth of 9.5 meter, a slight deflection of 20 mm was noticed, and it increased to 100 mm at 7 p.m. Excavation was stopped and workers were evacuated, but on the other side, where the excavation hasn't reached that much depth, still some workers were there. By 9:30 p.m., the shoring piles on the southern side came down suddenly. That is what we saw just now in the video. This video was taken by people in some people in the opposite side hotel, where they were interested in viewing that, and this video was taken by them. So this is the picture after the failure happened. This is the line along which the piles were provided. Where the Kochi Metro Rail is there. this is the adjacent building. See, if we can see that the soil is sunken from here and part of the foundation is being exposed here. The ground has cracks here. On visiting the site, these following observations were made. Due to the collapse of the touch pile system, the nearby road and earth had sunken by approximately 3 meters on the south side of the excavated area. Due to lateral shifting of the piles, the nearby earth was sunken on the southward side of the excavated area. And the building near the southwest corner had a slight tilt towards the east side, and cracks were noted in the building, and part of the foundation was exposed. This is indicative of progressive failure and may lead to sudden collapse of the building. But that building, luckily, was meant to be demolished, and then new construction was to come over there. So there was no problem with that. But if it collapsed and fell over, some casualties may have happened. But luckily, nothing happened like that. Cracks were noted at ground level in all the other 3 sides of the excavated area. The roads with pavement of interlocking tiles are differential settlements, and the tiles came, were dislocated. Public utilities such as road traffic, electricity, and water supply were adversely affected by the collapse. It also resulted in temporary halt of the working of Kochi Metro, since the structure was located near to a metro station. So, since such a big failure happened very near to the main road, collector intervened, district collector intervened, and a technical committee was formed to address the issue, to understand why it happened, and to provide remedial measures. Initial steps taken by the committee was to reroute the public traffic. Then the excavated area was asked to be refilled to reduce the retention height. Then sheet piles were asked to be provided in 2 layers to prevent further soil sliding. Then inside of the sheet pile, again, filling was to be done to counter the lateral forces. Then the core test and integrity test were asked to be done on the piles for forensic study. Then coconut piles were asked to be driven to stabilize the service road area for soil stabilization and for protection of water lines. Kerala Water Authority's lines were running along that area, and for stabilizing that. And an additional soil test was asked to be done to understand the soil parameters and check on, and to check do a check on the design of the touch pile system. So, as instructed by them, the area is getting, the already excavated area is being refilled with lateritic soil. Then soil stabilization is going on. So I already said this concrete core test was asked to be done on the piles for verification of in situ concrete strength of the piles, both touch piles and the soldier piles. Then pile integrity test was done to assess the depth at which piles failed and to check whether the actual pile depth matched with the design depth. 30-meter depth was specified in the drawing, and through pile integrity test we can understand whether the piles had gone to that depth. Then an additional soil investigation was done to understand the parameters of subsoil strata, and a proper structural analysis and design was done on the touch pile system using Plaxis and STAT software to identify the causes of failure, to check the adequacy of the system provided. So this part was done by geostructuralists. So this is showing how it is done. This is the pressure diagram that comes on a shore pile when it is excavated. When after this will be the ground level. When this much soil is excavated, this will be the active soil pressure, and this will be the passive soil pressure. So these are the different parameters we had taken. Design is carried out to retain soft clayey soil. soil parameters for calculations were taken from IS 2911, referring the soil investigation report. Obviously, the coefficient is taken as 10 kilonewton per meter square, and an angle of internal friction of the soil was taken as 15 degrees. And we cross-checked with the geotechnical consultant. With his approval, this value was taken. Unit weight of soil is taken as 18 kilonewton per meter cube, and the saturated unit weight is taken as 21 kilonewton per meter cube. Surcharge load of vehicular traffic is taken as 10 kilonewton per meter square, and the modulus of subgrade reaction is taken as 15,000 kilonewton per meter square. And this is the active earth pressure equation. PA is equal to Ka gamma H minus 2C root of Ka, where Ka is 1 minus sin phi by 1 plus sin phi. And passive earth pressure PP is Kp gamma H plus 2C root of Kp, where Kp is 1 plus sin phi by 1 minus sin phi. So these are the cross sections of a short pile and soldier pile. Short pile is 90 dia, and the reinforcement provided is 14 numbers 20 dia bars. For short pile, the diameter provided is 60 centimeters, and the reinforcement provided is 7 numbers 16 dia bars. With the diameter and the reinforcement known and the concrete mix used, we can understand what was the moment of resistance, what is the moment carrying capacity of the short pile provided. So with for 90 dia pile, mix M35 and 40 numbers 20 dia bars, the moment of resistance worked out to be in the range of 800 to 815 kilonewton meter. Now our endeavor was to understand to what depth of excavation these touch piles will be safe. Only in the front side the touch piles had totally collapsed. Other three sides the touch piles were still standing, and we had now stabilized that area by refilling. So up to what depth that touch piles will be safe without any other propping or strutting system was we tried to find out. So we modeled and found out for 5 meter depth of soil retention, 6 meter depth of retention, 7.5 meter depth of soil retention, 9.5 meter final depth of soil retention. So this is the pressure diagram prepared for 5 meter soil retention. The 5 meter depth of soil retention, point of rotation, that is, this is the distance at which the pile might rotate. So that from equations we can find out that, and that was found to be about 0.9 meters. These are the different parameters we have taken, and this is the output from STAT model. For 5 meter cantilevered pile, for the retention load of 5 meter, the maximum deflection noted was 43 mm, 4.4 centimeters, and the maximum moment that was coming is around 350 kilonewton meter. The moment of resistance we had assessed was in the range 850. So this is less than the moment resisting capacity of the pile, and so it will be safe for 5 meter retention. Then for 6 meter retention, the same procedure was done. And here the moment increased up to 633 kilonewton meter, and the deflection increased to 90 millimeters. The deflection is slightly higher. However, since this is the temporary structure, this can be taken as okay. And the moment also was within the moment resisting capacity of the pile, taking a factor of safety of 1.3. For 7.5 meter soil retention, again the point of rotation and the pressure diagrams were calculated. And when we did the analysis in STAT model, it was found that the deflection increased to 178 mm, and the maximum moment was seen to be 1110. So this obviously is unsafe, because the without factor of safety itself, the capacity of this pile is 800 or 815 kilonewton meter. So a bracing is needed to make the pile system safe for 7.5 meter soil retention. So this was the detailing of the propping system that they have earlier provided. So 1.2 meter deep, and this was around 30 centimeters, ISMC 200, and then two ISMC 200 laced with the 60 angle sections 65 by 65 by 6. So we modeled this. We modeled the entire touch pile system with the bracings in the three-dimensional model we created, and the loads were given accordingly. The supports were provided at the bottom with the lateral confinement. So this is the analysis results of the strut system provided, where unit ratio of truss element was checked. That means the actual stress in the element divided by the permissible stress should be less than 1, but we were getting values as high as 3.5, 3.7, etc. So this system was totally not safe to take up the loads, the huge lateral loads that were expected to come over there. So if we discuss on the analysis results, it can be seen that there is failure in the truss elements provided. Deflection and overturning moments are higher. Here the deflection is 132 mm and the moments are coming as 800 kilonewton meter. So if the truss element failed, then we cannot say that there is a propping action for the piles. So there will be no propping action and the deflection will be still higher. When we check the reinforcement required from the model for the touch pile system, the reinforcement required was 60 centimeters square, whereas the AST provided was only 44 centimeters square. For the soldier piles, the reinforcement required was in the range 40 centimeters square, 40 centimeters square, whereas the provided reinforcement was only 14 centimeters square. So the reinforcement provided for both the touch pile and soldier piles are less than what is required. However, if the propping system is more sturdy and safe and more number of propping systems are provided, the buckling of these piles will be less and the reinforcement required can be brought down. So what we suggested was that with the propping system, with the proper propping system, 7.5 for 7.5 meter excavation, the driven touch piles can be made safe. So since there is failure in the truss system provided, it was suggested to review and revise the design of the failed members in the propping system. That means the propping system, the prop provided has to be totally redesigned and provided. For 9.5 meter soil retention also, we did the same exercise. The point of rotation was found. Here it was found to be about 3.2 meters below the excavated level. And when done, we can see that when analyzed as a single member in model, we can see that the deflection comes to around 400 mm and the maximum bending moments comes to about 2090 kilonewton meter. So obviously this is not safe. So if we look at the reason for why the collapse happened, like I said, there was a technical committee formed and Association of Structural and Geotechnical Consultants in Kochi were part of this technical committee, and we all deliberated over it, and these were the reasons. Inadequate strut system. Obviously, if the strut system was proper, the propping action expected on the touch pile would have acted and it would have been safe. This the most important neglect happened in the design of the strut system. Then the topsoil is too soft. Soil parameters taken for original design may not have been correct, was what we felt. Then also some in the previous days before the collapse happened, heavy rains were there, and that might have caused reduction in the cohesion component of soil, thereby increasing the lateral thrust on the shore piles. Since the probes did not act properly, there was increase in the unsupported length of pile, and of course, which means that cantilever action ensued and the collapse happened. If this 9.5 meter total excavation was needed, we felt that if a second tier of strut system was provided at a lower depth, the same diameter and reinforcement for the touch piles would have been safe. This, since it was a public, public was involved and a technical committee was formed, these were the findings and suggestions of the scrutinizing team. The team scrutinized all the approval documents needed for the project and they were found in order. That means the permissions taken from the government authorities extra were checked and they were found to be in order. If adequate bracing system with higher sections and proper balanced geometry was adopted, the present touch piles installed can take up the lateral earth pressures due to the excavation up to proposed depth of 9.5 to 10 meter. And since it is a three-dimensional area where the corners are there, cross bracings with diagonal cross bracings should have been provided to bring in the required rigidity to the bracing system and prevent torsion being developed due to the lateral pressure from orthogonal directions. They also suggested to increase the setback of the touch pile system near the road by additional 4 meters. That means near the road, the collapse has already happened, and there driving again touch piles is not practical. So the basement was asked to be reduced. The extent of basement was asked to be reduced by 4 meters from the road. The committee felt that the collapse of the touch pile system of the building should serve as a wake-up call to the authorities and engineers in the construction industry. It is only by sheer luck that there was no loss of human life. There was only one building close by, and this was to be dismantled. Hence, even if some cracks developed in that building, it was of no consequence. With the workers in the excavated area and with the buildings close by, it could have been not just a failure, but a catastrophe. What did we learn from this failure? We learned that proper site investigation. By proper site investigation means what all things are expected in the project that we are handling. We have to understand that what type of soil investigation, what type of lab results needed, etc., are to be understood in the initial stage itself, and the geotechnical consultant should be briefed and whatever data needed should be obtained from him. So the importance of proper site investigations cannot be emphasized enough. Understanding the site conditions, the various parameters that can affect the design of such shoring systems should be judiciously and cautiously done. When such public areas are encroached upon, a bit conservative design would have been better, and such failure could have been avoided, is what we felt. So it has to be judiciously done. It is the prerogative of the design engineer to understand what are the site conditions, what can go wrong, and then design it with a cautious mind. A rigorous analysis and design of shoring systems for such deep excavations should be done. A rigorous analysis and design should be done. Here, we felt that only a two-dimensional analysis was done. Rather, a three-dimensional analysis should have been done, and the soil parameters should have been judiciously taken. And a peer reviewer should be engaged to avoid such near catastrophic situations where general public also comes under thrust. A peer reviewer will find out if some overlooking has happened in the original design. So checking with another peer will be helpful in such cases. Forensic studies on such failures should be done. So rather than hushing up the incident and doing no postmortem, we should understand such failures, and we should talk about such failures and study such failures so that in the future we can avoid such happenings. So now we come to a case study of fourth case study. This is a hotel building at Kottayam. We were involved in the first stage of the construction, and later when some mishap happened in the building, we were contacted, and in between they contacted some other consultant too, and some constructions were done. But later when a failure happened and they couldn't control it, we were asked to intervene and give solution. This is actually a small building with a G+2 floors. Only 3 floors are there. It's a hotel building, and total height of the building is only 9.45 meters. So the floor heights are as shown. What was the problem was, after 2 to 3 years of construction, cracks were observed in the building. Cracks were observed means in the block works, cracks were seen. So being a hotel, that cannot be permitted, and investigations started as to why these cracks are formed. We couldn't find out any cracks in the structural elements, and after continuous observations and taking readings, etc., it was found out that the cracks were due to differential settlement of foundation resulting from mass movement of soil underneath. The building, along with the piles, seemed to have been pushed, and this slanting, this out of plumb action of the building caused the cracks in the masonry walls. So this is again, it is explained here. After 2 to 3 years of construction, cracks were observed in the building. Further investigations were done, and it was found out that the cracks were due to differential settlement of foundation system due to mass movement of soil underneath. So what is mass movement of soil, and how does it happen? This mass movement means bulk movement of soil and rock debris downslope in response to the pull of gravity or the rapid or gradual sinking of the Earth's ground surface in a predominantly vertical direction. Various factors can be attributed for such mass movement of soil. Weathering or erosional debris cover on slope. On slope, if erosional debris are there, this may cause a mass movement of the soil. Then character and structure of rocks, such as resistant permeable beds prone to sliding because of underlying impermeable rocks. So on the top of impermeable rocks, if permeable beds are there, they may tend to erode or move as a body. Then removal of vegetation cover, cutting of trees, etc., can cause this. Then artificial or natural increase in the slope of the slope steepness. So the slope steepness of the slope can be changed due to artificial or natural causes. Then earthquake, tremors, flowing groundwater, etc., can also be attributed for such mass movement of soil. Effects of such mass movement of soil will cause damage to encased piles. Encased piles means these piles are encased in these soils, and when these soils move as a mass, they will be damaged. They may buckle, they may break, then it will cause lateral and vertical movement of the building, and then the nearby areas also may be affected by such mass movement. Then this building will be out of plumb, and it will further aggravate the situation. So, like already explained, after 2 to 3 years of construction, settlement or mass movement of soil beneath the pile foundation was observed. The settlement of front block was observed to be more than the settlement of back block, which resulted in the creation of crack, that is unequal settlement. So this is the road, this is the front block. Then there was an expansion joint provided. The length of the building was more than 110 meters or so. So we had provided an expansion joint. So this is the back block. Here, in this highlighted area, the settlement was more compared to this area. So if we look at the settlement values here, You can see this is 8.7, 8.5, etc. But here it is 10.5, 11.8, 12.1, 12.8, 13.3, 14.3, 15. So there is a slope in this direction and in this direction too. So the buildings seem to tilt towards the expansion joint. So in the initial stage, what we did was the existing building was supported with the props and show walls. Facade walls constructed were demolished to reduce the load on the foundation system. And then to avoid further movement of soil, Casuarina poles were driven as touch pipes, touching each other along the periphery of the building. Then two piles mostly affected in the area where this maximum sinking has happened were underpinned using additional two piles. After this underpinning, settlement was found to be within limits and further settlement was arrested. So the building was operational and serviceable. So this is where we did the underpinning of two piles. Here there is a column, there was a pile. There is a column, there was a pile. So they two were connected and two piles, additional piles were driven and a cap in this shape was provided to underpin the structure. However, after 4 or 5 years, they made some changes in the building with another consultant. They made some interior design changes, and along the expansion joint, slabs in the ground floor was demolished and some changes happened internally in the building. So when the status quo was broken, the building again started to move and differential settlement increased and cracks were started to develop. In the second time, the cracks extended to the columns also in the expansion joint area. So when they saw cracks developing in the columns also, they again came to us. We studied the situation and underpinning was proposed as a solution. And we have a retrofitting section division here, and the retrofitting was done by ourselves. So we prepared the drawings for retrofitting, and while execution, the challenges faced are like this. The solution was prepared considering that all the pipe caps are at the same level, because as per our drawing, they were to be at the same level, but at site, due to some service lines closing, etc., they had done the pipe caps at different levels. So the underpinning was not possible at one level. So after excavating the site, it was found that the pipe caps were not at the same level. So the design was modified to suit the site conditions. This is the building. So this is the expansion joint area. This is where, so inside the building also we proposed underpinning. This is the area. So here and here. Here we have already done. So in addition to that, this much underpinning was proposed. So this is the basic drawing provided for underpinning. These are the existing columns and piles. These are the additional piles provided. This is the shape of the pile cap we proposed for underpinning. This is the existing pile and the pile cap, and this is the underpinning proposed. Stages of execution. This total station survey for measuring the current level of settlement was done. Then propping of the building was done. Then piling operation was done, because inside the building also we had to do the piling. Then ready mix concrete of M30 grade was used. Pile cap construction with self-compacting concrete and kilting for anchoring reinforcement into the existing pile caps were used. Then column jacketing was done for 3 columns near the expansion joint where excessive cracking was found. So like I said, to suit the site conditions, we had to do, since the pile cap was for certain pile caps were at a lower level, This is the additional pile provided, and we provided a pile cap encompassing the already existing pile cap. A design was given like this. This is a modified design from the earlier one, and this was done at site accordingly. Then we, after this retrofitting works were completed, we monitored the settlements for 1 year. So these are the different values we have checked. These are benchmarks established, and the readings of settlements. It was seen that the levels were stationary and there was no further settlement after the retrofitting works were completed. So some site pictures. So how the surveying was done to establish benchmarks and the levels of the pile caps. Then excavations were done for pile cap and construction of the pile caps. The steel caging work is going on. How we did the piles inside the building in the expansion joint area. Then concreting, here pile chipping. Then excavation, the pile cap is excavated, existing pile caps are excavated. Then PCC for pile cap is being done. So if you can see, this is the shape of the pile cap, how it is being done, how it is shuttered up, and concreting using self-compacting concrete. Then tie beams are established. Then backfilling, column jacketing, decking sheet was used to cover the dismantled connection slab at the expansion joint area, and this was topped up with concrete. So that retrofitting part was completed, and till now we have not heard of any further settlement from there. So what we learned from this was a small building, and DMC piles anchored into hard rocks were provided as foundation system. So such unequal settlement was not expected in such a small building, that too with the piles anchored into hard rocks. So this, so we understood that sometimes such unexpected natural causes may lead to failure of a well-designed structure. Initial investigation, once such failure is noted, should be done to check and understand how critical the damage is. Immediate rectification measures should be done as required. This is necessary to arrest further damage to the structure. Damages in structures should be identified correctly, and the cause of damage should be investigated and understood. Necessary tests should be done depending on the observed failure. Depending on the failures we have observed, we must decide on what tests are needed to be done. From the test results, a decision has to be made whether to demolish the structure or to adopt any strengthening methods to resolve the issue and retain the structure and make it serviceable. Accordingly, the structure may be redesigned considering the loads expected. So the next case study I am going to present is one tower building, one church tower at Trichur. The mistake or the failure happened. There is no failure as such happened. Only thing is the construction of this church tower started in 1929 and completed around 1940. The envisaged height of the tower was to be 70 meters, but maybe due to a lack of funds, or maybe due to fear of raising the tower to that much height, the tower was topped at 70 meters or so. So later in 2000, we were asked to raise the tower to the original intended height of 70 meters. We have no documents or design drawings or design documents of the building. So that was the challenge faced by us. And so I would like to share our experience in doing this with you here. So this is challenges in the addition and alteration of monumental structures, a case study of Bible Tower or Puttanpalli, as is known here at Trichur. The shrine was established as a parish in 1978. In 1992 April, the then Pope John Paul II elevated this church to the status of a basilica. Foundation stone for the present big church was laid in 1929 by Bishop Mark Francis Varapilli, and it was completed in around 1940. The salient features of the church include beautiful twin tower in the front and a taller single in year 2000, project engineer there, late engineer James Alaphat, entrusted the structural design part of raising the tower from the constructed height of 16.5 meters to its earlier intended height of 70 meters to assess rear structurals. So this is the tower as envisaged by the original architect. This was the height. This is what he intended in way back in 1929, but it was constructed only. This is about 70 meters height, but it was constructed only up to 17 meters height. So the foundation stone was laid in 1929 and completed in the church tower was completed in 1940, around 1940. And we were asked to increase the height of the building in 2000, and we started the work. The construction work was started in 2000, and the work was completed in the present stage in 2002. So the problem that we faced was the back tower was not raised to the full height envisaged by the original architect. Restarting the construction after nearly 70 years to raise it to the original intended height was our problem. So these are the problems to be sorted. The tower has to be raised from its completed height of 16.5 meters to the original envisaged height of 70 meters. Foundation has to be constructed from within the limited space available of 5.35 by 5.35 meters. This is the size inside of the church tower, which was raised to 17.5 meters. So only this area is available for us to provide as foundation for the tower to be raised up to a height of 70 meters. And absence of structural drawings or documents added to the challenge. I'll run through this. This is the churches of Gothic style, and the height of front twin towers envisaged was 50 meters, and height of back tower envisaged was 70 meters. So what we did was we did a detailed study of the problem at hand, and review of the existing structure and details was done. Then we identified possible problems, and then we prepared a conceptual design. Then a preliminary design was done, and then we zeroed in on the system to be followed, and then the detailed design was done. For the existing structure, the old foundation provided was from a depth of 4.5 meters commencing from hard laterite. This we understand from a architectural drawing, the section was shown. So from that we understand that the foundation was provided at a depth of 4.5 meters from the ground level, starting from hard laterite soil. Bottom 2.4 meter depth comprised of lime concrete. Width of wall footing was 4.5 meters at bottom. Above that, rubble masonry was noted up to with a width of 1.8 meters. Above this, ashlar masonry was seen up to 5.5 meters, having a width of 1.2 meters. And then 1.05 wide brickwork was shown till the total height of 16.5 meters. This is the sectional drawing made available to us at that time. So this drawing shows the top of 16.5 meters. So we are not sure whether this foundation was designed for 70 meter height or not. There are no calculations or other design details. So we were not sure whether we can just raise above the 16.5 meter. So that cannot be done. Load calculate. Then what we did was we, as for a new building, the detailed loads were calculated, and the structure was analyzed for seismic loads as per IS 1893, and all the loads, that load, line load, wind load, all every loads expected on the building were taken, and all the combinations possible were taken, and the building was designed. For designing the building, we have to have a structural framing work. So for that, what we did was, this is the problem statement. Existing portion of back tower was in masonry. Tower was now to be raised from 16.5 to 75 meters. From 70 meters, with some other additions, with the additions suggested by the church people, they finalized on a total height of 75 meters. Construction of back tower was in no way to hinder the church proceedings. The church proceedings were going on, and we couldn't hinder the church proceedings in any way. So we did not have the freedom to do an external work, to do some columns outer of the tower and then raise it up. We cannot do that. So we were allowed to do only work from inside the existing tower. So existing church could not be dismantled or affected. So, so this is a tall structure, and the width of the structure that was made available to us was very small compared to the height proposed. So it has to be treated as a tall structure. For very tall, slender structures, it is necessary to develop as much lateral strength and stiffness as possible. The use of 4 shear walls interacting together with the exterior moment-resisting frame has been successfully used in tall structures. The tube-in-tube system, with the excellent overturning resistant ability of the facade frame, combined with the shear resistant capacity of the 4 shear walls to achieve a highly efficient structural system. Such a system has been successfully used in the construction of the Sears Tower in Chicago. So we deliberated upon many systems, and this was the system we finally adopted in the design of this Bible Tower. Since it was felt that raising the structure as masonry work above the existing structure was risky, it was planned to raise the tower up to the envisaged height of 210 feet by new construction commencing from foundation level. It was planned to provide a central shear wall from the inside space available and cantilever the central shear wall to match up with the system planned by the original architect S.A. Gnanapragasham. For the purpose of deciding the foundation needed, it was decided to conduct a new soil investigation. Since it was noted that the construction of pile foundation is not possible from the constrained space, it was decided to make foundation by sinking well anchored into hard rock in the limited space available between the existing foundation, and to concrete the entire inside portion of the well to make it as a massive monopile commencing from the hard rock strata. So we had about 2.5 meter size, some square 2.5 by 2.5 meter size inside the existing foundation, free for doing this piling. So there we sank a well, then excavated soil up to the hard rock, then rebars were anchored into the hard rock using gilty, then concreted till the top, and the inside space was concreted again using additional reinforcement. It was also decided to provide outer columns from pile cap and to commence new column from the top of existing structure. So for the preliminary design itself, we did 5 different trials with the inner core wall only, inner core wall plus outer core wall with the supports above masonry wall, then outer inner core wall plus outer column without supports, then inner core wall plus outer column plus full brick wall bracings and supports. Then this full brick wall bracings were reduced to half brick wall bracings. So these systems we tried to understand which will give a best result that is suitable for this purpose. So I'll go through these different options quickly. So this is the model for 4-wall alone. Then we checked the deflection and the total loads coming on it. Then this is the outer core. Earlier diagram, if you see, there are no outer columns here. In the second option, what we tried, we provided outer columns here, cantilevered from the inner core, but they were supported on the existing masonry wall. So slight load will be transferred to the existing masonry wall. This was our concept. The adequacy, I mean, what are the forces coming and the stresses coming, what are the deflections, etc. were checked. Then the outer columns were provided, but the outer supports on the masonry walls were omitted. In this case, we had to understand whether this will be self-standing itself without relying on the strength of the existing outer walls. That also analysis results were checked. Then outer, this is the bracing system provided. What does that mean is, in the outer facade, we can provide brick walls, and the bracing effect of those brick walls were taken as cross diagonals in the model. So this was taken. Then those walls were reduced to half brick wall because the loads can be reduced on the foundation. So we thought, if we try with half brick wall, what will be the effect on the effect after the analysis? So all these things were done, and all the 5 cases were the results were plotted on a table. And if we look at it, we can see that the deflection from 643 mm is brought down to 80 millimeters, 643 millimeters to 80 millimeters when the bracings are provided. So we compared the different systems. What we found out was that there was not much variation in the loadings and the deflections or behavior of the structure when the outer walls were half brick wall or full brick wall. So we opted for the full brick wall option. So this was the preliminary design, and then finally the final design was done with the option of outer columns, inner core wall, and outer walls provided with full brickwork. So this is the drawing of Jnana Prakasham sir, and this is how we modeled it. Each portion is shown here. So in between portion, the model was like this. So outer walls, this is the outer walls. So here we can provide outer walls. So this was his this section provided by him. This is how we modeled it. So this slight slope is seen because we did not have the this much space in the inner core inside the building. So from there it was slightly inclined columns were taken, but the sheer inner core is taken through and through vertically. The outer columns are slightly inclined and then supported on the masonry wall. So as we have already explained, all the different loads possible on the building were taken. There was also a technical committee with the engineers from the church side, and ourselves and public people were there. We all discussed, and the loads etc. were discussed. A peer reviewer was there. They also checked, and the analysis of the building was done using StatPro package. The loads, as I have already explained, dead load, light load, then wind load in X direction is a direction, then perpendicular to the diagonals also was taken to understand any torsion development in the building. Then the seismic loads were taken, and the combinations of all these were taken. And from the analysis results, all the load combinations possible, the maximum load coming on the foundation was cross-checked with the capacity of the foundation system provided, and the design of monopile was accordingly done. And each of the structural element of the tower was designed for the worst combination of loads, and detailing was accordingly given. So what we learned from this project is that absence of, we can design anything, but to start a restart on a project already done is more challenging than doing it first time. So proper documentation is a necessity for any building. Starting new construction from an already constructed building is more challenging than doing it first time. The original or existing structure has to be studied, understand where there is flexibility to accommodate further loading and retrofit where needed. Proper system to connect the new construction with the old one has to be envisaged, designed and executed at site without deviation. So, hello, Dr. Neetu. Have I exceeded the time allotted? Hello? Hello, Dr. Neetu.
Yes, ma'am. Yes, ma'am.
Have I exceeded the time allotted?
No problem, ma'am. No problem.
No problem. Okay.
Yeah.
So these are the 5 case studies I had prepared to present here. So
Yes,
I
ma'am.
think I do hope that this was useful for to you, for the students here. So, and I thank you for this opportunity given to me to address you in this auspicious day.
Thanks a lot, ma'am. We are very thankful to you. You have explained each and every unique failure in detail and what are the remedial measures for the same. So if any of the students or anybody who has logged in has any doubts, you can ask ma'am. You can either unmute and ask her directly, or you can type it in the chat box.
Yeah. I think the presentation was way too long than the students expected.
But still, we could see that almost everyone were there, ma'am, till the end. So it was like I got some personal messages saying that ma'am has explained it in detail so that we did not get any doubt, because
Yeah.
all the remedial measures were explained in
And,
detail. Yeah.
So
I
like
think,
I said, yeah, we have to learn from such mistakes or errors happened at site. So errors are bound to happen. So what
Yes.
we can do is understand the reason, understand the cause effect, and then learn from them and move forward.
Yeah, the same mistake should not repeat.
Yeah, same
That's
mistake
what,
should not.
yeah.
Yeah.
Ma'am, we
So
had
we-
some MTech structural engineering students also who had logged
Yeah.
in. So I
Yeah.
think it was very, very beneficial for them.
Yeah, I
So
hope
they
so.
have studied here.
Yeah.
We'll just wait for one more minute, ma'am. If we don't
Yeah.
get any questions, we can.
Yeah. So I'll just share my last this thing, since I thought I had exceeded time too much. I just closed my. Shall I share once again? One just slide.
Yes, ma'am. Yes.
So on conclusion, I would just say that forensic studies on failures always give a deeper insight into the practical engineering issues in the designing, planning, and execution phase of a project. Reflecting on these failures will give us valuable lessons for the future construction practices. From most of the failure analysis, it is seen that by knowing the basics and practicing them, many failures could have been avoided. A scientific thought process with cause-effect understanding is needed to avoid man-made failures. So as we know, the famous philosopher John Ruskin had said, when we build, let us think that we build forever. Let it not be for present delight, nor for our use alone. Let it be such work as our descendants will look upon with the prize and thanksgiving in their hearts. And success is when persistence meets preparation. It is not by luck that anyone succeeds. It is by persistence and with the proper preparation. And quality is never an accident. It is always the result of intelligent effort. So thank you once again.
Thank you, ma'am. Ma'am, if you don't mind, can you just type your email ID in the chat box so that they can mail you if they have any questions?
Yeah.
Meanwhile, I request Mr. R.P. Malik, Chairman, IPHE, to propose vote of thanks for today's event.
Thank you very much.
Thank you, sir.
You can hear me then, okay.
I think your
So-
voice is breaking, sir.
Now,
Yes, sir, it's clear.
yeah. So on this auspicious occasion of Engineers Day, on which day we are remembering Sir M. Vishwesvaraya, it is very pertinent that Vishwesvaraya was always open. So today, the topic you have selected, the madam which presented on this occasion is learning from mistakes, case studies. Very rarely we have opportunity to have a deep view or deep insight of failures in civil engineering. Failure of a civil structure is always a challenge for a civil engineer legally and financially. But civil engineers must use it as an opportunity to learn from these mistakes, somebody else's mistakes, and improve upon their working. The study of failure and remedial measures are a learning topic very rarely taught in any colleges or any departments. So what I learned here is data from the field, analysis and design, execution as per design, using raw materials, workmanship, and implementation. These are the several stages in any civil engineering project that will take care of that there should be no failure and the intended object of the construction is properly done. Madam Bindu Sunil has given a very good example, very well explained. Of course, we are very much interested not only in the failures, but also in the remedial measures they have taken in these 5 case studies. So on this occasion of Engineers Day, first of all, I should thank Dayananda Sagar College of Engineering, Principal Prakash, HOD Dr. Ramaraju for arranging this seminar, very enlightening seminar to the budding engineers as well as practicing engineers. At the same time, I also thank our Indian Waterworks Association Chairman, B. Srinivasa Reddy, and the coordinators, Dr. Neetu, Dr. Soumya, Professor Meghashri, and also all the participants for participating in this very, very important topic, because as they told in the beginning, error of an auditor will kill one person, error of a civil engineer will kill several 100%, may kill several 100%. So I thank each and everyone for arranging this seminar, webinar, as well as attending the seminar. Thank you very much, madam. A special thanks to madam for giving such an insight to failures and the remedies suggested by them in these 5 case studies. Thank you, one and all.
Thanks a lot, sir. Thank you for the detailed vote of thanks, where you have noted down what Madam spoke about in length about the structural failures, mistakes, and learning from the same. Once again, I take this opportunity to thank you all for taking time to attend this wonderful event to commemorate our Sir M. Vishwesvaraya's 162nd birthday. I wish you all again a very happy Engineers Day. Have a nice day, everyone. Thank you.
Thank you all.
Thank you, everyone.
Thank you.
Thank you.
you all.